go ahead and I'll hand it over to you, Jacob, for control flow.
Excellent. Control flow, chapter 5. This was another, I felt like this was a really short chapter. I think it's only like 10 pages in the actual print book. But I felt like there were a lot of good nuggets in here. So I've got my presentation set up. I'll go through the highlights from this chapter, and then if we've got time and want to, I have kind of the quiz and exercises laid out along with the answers, so we can go through those and discuss as needed. Learning objectives for this chapter are understanding the two primary tools for control flow. Hadley breaks them into choices and loops. Learn the best practices to avoid the common pitfalls when executing control flow. And then is distinguish between if else, and switch for choices, when to use each, and distinguish when to use a for loop, a while loop, or a repeat loop. Hadley makes the note in the chapter that he assumes basic familiarity with choices and loops, since this is an advanced R book. And I'm going to do the same as I go through my presentation. I'm going to assume everybody has done a for loop in R and some sort of an if statement. But I would say if you've got questions as we go, feel free to interject. But I won't dive too deep into the basics on either of those in the slides. First section in the chapter is choices. If is the basic statement for a choice, and he points out that there's a single line format that we can use, but more often it comes in a compound statement surrounded by braces. The results of an if statement can be assigned. This is one that I actually didn't know until I read the chapter, that you can take the result of an if statement and assign it back to a variable. And Hadley recommends, though, that you only do this really when there's a single line format, because it can be really hard to read and follow the code if you use the compound statement format and assign all of that back.
Have you tried doing this without the else statement? Like, what if you had just like if false one? Like, oh, I guess that wouldn't be syntactically correct, I guess.
It worked.
It would be,
It,
and it does work. He goes on
yeah.
to bring up that's a great transition, Nick. He goes on to say if without else can be combined with a C or
Mhm.
a paste to create a compact expression. When you don't have the else, a null gets returned when the
Mhm.
value is false. And he has a little toy example that demonstrates this. So it's a function that will greet somebody and say happy birthday if you pass along if it's their birthday. So if birthday if birthday is true, it'll return and happy birthday. And if it's false, it just returns null. And then that null gets ignored by the paste statement.
Mhm.
If should have a single true or false condition. Other inputs generate errors. I can't say how many times I've been bit by this one, especially the last error, where the condition has length greater than 1. That seems to be something I constantly fight in my code. So Hadley gives some examples here of error generating conditions. So in that case, you use if else for vectorized conditions. So the example here is if x is 1 through 10, um, you can compare each condition individually, and if else will return a vector. The important tip here that Hadley makes is that only to use if else if both results for the true and false are of the same type. He says otherwise the output type is hard to predict for the if else function.
Mhm.
He also mentions that dplyer's case when can be used similar to if else for multiple vector or condition vector pairs. And case when opens up having multiple different true conditions. Is everybody familiar with case when? He doesn't really go into it much in the chapter, but it does have this kind of special format to evaluate each condition top to bottom, and then the first condition that evaluates as true, that result is returned, and then it moves on to the next item in the vector.
Yeah, I've noticed that like you have to be very careful with like these case ones, because like you said, the first statement if that becomes true, that's what's chosen in return, and that's it. Doesn't go to the next ones and the next one. So like it's better to like have your first statements up front that are probably like I don't know. The ones that I put up front are like I'm okay with it returning early. That's how I think of it.
Yeah, I think of it in terms of like it's like a priority list, right? Of
Yeah.
what you want returned. So you got to make sure that if something could hit more than one of your conditions in case when the one you really want has to be on top, because
Yeah.
that's going to be the one that gets returned.
Yeah. So I guess it's helpful if you like I've already thought about like that the conditions are like mutually exclusive. Because I have been bit where I'm like it actually can mean like more than one of the conditions and that's not great.
Yeah.
Or you don't expect it.
So Hadley also introduces the switch function, which is a special purpose equivalent to if that can be used to compact code. In the book, he takes the example, the code on the left and the code on the right do the same thing, but you can see the much more compact uh, version when you use switch. And he's got a couple of tips when using switch. He recommends that the last component of your switch function throw an error. Otherwise, unmatched inputs will invisibly return null. That was a new one that I didn't know about switch. He also said switch, he recommends only use it with character inputs. It's possible to use numerics, but they're hard to read, and he talks about undesirable failure modes. So his recommendation is just to stick to characters. And I'll add in my own caution when using switch is that like if it can only take a single condition, I always want it to be more like dplyer's case when and take a vector, and usually that results in an error for me. So switch like if you got to pass it a single value into that. Switch also has a special feature where you can avoid repeat outputs by leaving the right-hand side of the equal empty, and then it will fall through to the next value. So in this example, uh, cow and horse don't have any value after the equal sign, so if you pass it cow or horse, it falls through to dog equals 4, and you get returned 4 for all of those.
I don't like that behaviors. I don't know if someone like that behaviors, but like I can totally see someone updating that list and forgetting that, and we screwed.
Yeah, I can see the value in terms of like not having to repeat your code a lot, or if you've got a really long list, and there's only like two values out of it, it'd be helpful. But I also see the gotcha of forgetting that it falls through when you update things. So then we move into loops, the second section of this chapter. To iterate items in a vector, use a for loop. The basic format of a for loop is for item in vector, perform the following action. So we have a simple print example here. And Hadley notes the convention of using short variables like I, J, or K single letters for iterating through these vector indices. An important tip that I also didn't know until reading this chapter was for will overwrite existing variables in the current environment. So you have to be careful when choosing your iterator variable. In this example, I is given the value of 100. And then once the for loop hits, it overwrites that value. And has the final value of 3 when it's done.
I
So
think it's, yeah, I like these behaviors.
it makes sense, right? Because we're working in the global environment. But it's just not one that I had thought of in the past.
You can also like debug your for loop, calling the last I'm gonna call that an iterators, but it's probably not exactly an iterators. So calling like I'm gonna show what's the previous before it's break. So
Yeah.
it can be useful sometimes.
So use next and break to terminate loops early. Next exits the current iteration, and then the loop continues on to the next iteration. And break will exit the entire loop and move on in your code. So basic example here, he combines his if statements to say that if I is less than 3, we just move on to the next iteration, and then after that we print I, and if I gets higher than 5, we break the loop. So the end results are we skip printing 1 and 2, we print 3, 4, 5, and then when 6 comes around, we get the break. He recommends to pre-allocate output containers to avoid slow loops. I know this is a common one. And so what does that mean is to create essentially an empty vector of the type that you want, and the length that you know your iterations are. And that speeds up the execution. And he references that they go, I think this will go into a little more depth in the performance chapters later on. He has a tip here that vector is a really helpful function for pre-allocation, and I wasn't really familiar with the vector function before reading this book, so it makes a lot of sense to easily and explicitly create an empty vector of a certain length. In this code, he's creating a list that'll end up at length 3.
So I guess it like creates the memory slots almost.
Yeah, exactly. I think it has to do with when you expand. If you don't pre-allocate every time the vector expands, it ends up making like a copy to do that. And so your memory grows and it becomes a lot slower.
Mhm.
That one
He also,
is like it's less of a thing these days. I haven't run the tests recently, but I know that I don't know, R 4 point something does better with the allocation. I think it's still worth doing, but it's like it's less and less important as they fix things in for R.
Which is awesome.
Yeah.
yeah,
It's still good as a debugging tool also, because like you basically create
That's
a
true.
vector that you should, I mean, it should be empty if your for loop does something weird, or it should have some elements that are not fully populated.
Yeah. The thing that's really nice about it is like if you don't know how long your for loop's gonna run, it used to be that, well, you're screwed, and you could like over allocate was the best you could do usually, and then get rid of all the extra spaces. But it's like I said, I haven't rerun it. I can't remember exactly what changed, but I remember something changed that impacts this.
So the next tip that Hadley gives is to use sequence along instead of, 1 : length X, which I find funny because in all his examples up to this point, he uses 1 : length X. So obviously he's setting up for the reveal on this one. The reason is that 1 : length X causes unexpected failures for 0 length vectors, and that's because the colon can have both increasing and decreasing sequences. So in the example here that he lays out, if you have an empty vector of means, then 1 : length means returns a vector of 1 and then 0. And if you compare that to sequence along means, it just returns an empty integer vector. And so then we can compare the code using one colon versus sequence along. And you can see that the code on the left results in an error. And then the code on the right just results in an empty list. And the empty list is probably the behavior we would expect from a zero length input vector. He also recommends using sequence along to avoid problems when iterating over S3 vectors. He states that loops typically strip the attributes when they iterate over a vector. So this example, he's using dates. And he shows that if you directly iterate over that date vector, the attributes that cause it to print nicely as a date get stripped out and you just get the raw numeric format of the date, versus if you use the sequence along and then reference the item or the place in the vector, those attributes get retained. He says to use while and repeat loops when you don't know the number of iterations. So the while condition action performs the action on, while the condition is still true, and once the condition becomes false, the loop will stop. And then repeat action just loops on forever and ever until you issue a manual break command in the loop at some point. He says to always use the least flexible loop option possible. In the chapter, he talks about, any for loop can be turned into a while loop. Any while loop can be turned into a repeat. And so repeat is the most flexible, while is the next most flexible, and for is the least flexible of those three. So the order to use those in, he recommends, is try it with a for loop. If you can get it to work with a for loop, use that. If you can't, then use a while loop. And if you still can't get it to work with a while loop, use a repeat. He also mentions that if you're performing data analysis, you probably don't even need for, while, or repeat. And that an apply or a per map function are going to be even less flexible than a for loop, and you should use those options first during your data analysis. And that's the end of the short chapter. So we have plenty of time. You guys want to go through the quiz answers? I think there's a couple of good things that get explained in some of these questions.
Yeah.
Yeah, so the first up, well, this kind of goes straight down, quiz, then the first group exercise, and the second ones. I pulled the answers out of his answer book, and most of them are verbatim if they're short, and I did some bullet pointing for some of the longer ones. But the first question is, what is the difference between if and if else?
If else is vectorized.
Yep, that's pretty much it. If else is the vector version. The second quiz question, in the following code, what will the value of y be if x is true? What if x is false? And what if x is an NA?
Hmm. 3. No.
3. The other is probably null, and I should try.
I think it errors, right?
Yep. So
Yeah.
his answer is that if x is true, y is 3. If it's false, then we return that null that we
Yeah.
learned, that null behavior. And if it's an NA, then it throws an error.
Yeah, that's if else who does another behavior.
Differently, yeah. Well,
Yeah.
yeah, that's
Yeah.
one of the later questions he gets into that. And then what does the following switch code return for X?
2.
Error.
Yep.
Oh, 2. Yes, 2.
Yep.
Yeah.
The switch statement uses the fall through, so it returned 2.
So weird.
I also discovered when I was reviewing these slides, I put a typo in here. Actually, I have X equals blank, Y equals 2, and then I have X equals 3 again. I tested this code and it actually still works. So this fall through behavior is similar to kind of that dplyr behavior we were talking about. And if there's a later version of X, it just gets ignored, which I thought was kind of interesting. What type of vector does each of the following calls to if-else return? And he recommends reading the documentation to write down the rules in our own words.
The first one returns a numeric value of 1.
Yep.
So then,
Should I keep going or yeah?
Yeah, we can
I'm
go into
trying.
the answer if you've had a chance. So he kind of summarizes the rule here. In general, if else returns the entry for yes when the test is true, the entry for no when the test is false, and NA when the test is NA. And so, yeah, we expect the first one to return a numeric vector, the second one to return a character vector, and then the third one to return an NA. And he goes on to talk about that in practice. And I didn't know this about if else, and it's kind of interesting. The test condition gets converted to a logical first, and then that logical gets evaluated for true and false. And if that logical, that as.logical test is neither true nor false, then the value of it is returned. So in the first example of this, he shows that, if you have an empty logical vector as your test, then you get an empty logical vector as the result of if else. And then kind of the conversion of NaN and NA characters result in NAs. If you pass just a straight character vector, that character vector, when you try and convert it to a logical, becomes NA, unless the character vector is the word true, in which case it has the ability to convert it into a logical of the value true, and you get that 1 returned. So why does the following code work? We're passing a vector of the values 1 through 10, and we're taking an if condition on the length of that vector.
One is true. This one is easy. The first element of 1 to 10 is 1, and 1 is 2.
No.
It's covered.
It's not
No?
the first element, it's the length.
Yeah, so it's returning the
Oh.
length.
The length of
Oh
X
my
is 10.
goodness.
The length of X is
Oh,
10. So we're saying if 10,
I use this all the time.
not empty, else empty. And this is a behavior I didn't know. So it's good to hear
So,
that, John, that you
length-
use it.
Yeah. So you'll see like if is null or is not, not is null a lot. And I like length for most cases better because then it works for either null or an empty vector, which often you want it to be the same of you didn't give me anything or you didn't, you gave me something that is empty. And so I use length of X to do that. It's like shorthand for is null or length 0. Yeah.
Yeah. And in the book, you talked about this, the behavior is based on the fact that if you pass in a numeric vector for your logical condition, 0 is treated as false and all other numbers are treated as true. So when we pass if 10, it turns that into true. It's kind of an interesting choice in the behavior that they programmed in.
JavaScript will do it for like anything not empty is true. So, which can be really, like there are times that you can make some really short code because you can basically say, this character vector or not, sorry, this string or some other value. And it's like, well, that string is empty, so I'm going to use the other value because it, it takes the empty as false and has to evaluate the or. It's, things like that can be interesting, but we don't have that.
Hmm.
The next question, why does this code succeed without
Mm-hmm.
errors or warning? So we have X as an empty numeric vector, and then we pre-populate our output vector to be a list of the same length as X.
Okay.
And then in our for loop, we're looping over in the way that's not recommended by saying I in 1 to the length of X. We're taking and storing that, taking that value X I squared and storing it back in that list. And the output of this all is a single NA in a list.
He has a strange definition of succeed there.
Yeah,
It
that we
throws
never
no
go.
errors. It throws no errors is
The
a
loop never
success.
Yeah.
the loop exit and we just get out, no?
No, because it's going from 1 to 0.
Yeah.
And
So
Oh, it
I'll
went backwards.
so
Yeah.
he's got a bunch of bullet points on this. And this is, I thought, a good one to walk through. So I've got the code step by step after this, but it really has to do with the subsetting behavior of a single bracket versus a double bracket when it comes to out of bounds and zero indices. And if I recall correctly from the subsetting chapter, a single bracket tries to return the same type of vector when it's out
No,
of bounds.
that's the second bracket, no? The
Yeah, the single. And so essentially when you are running this, you end up with an empty vector when you evaluate it at 0. So the first one, x1, generates an NA, and an NA squared is NA, and that gets assigned to the first part of the list. And then the X evaluated at position 0 with the single bracket returns an empty numeric vector, and that gets assigned to an empty list. And so each step is technically a valid R operation, although it doesn't give you what you think it would. So I put it all to walk it through. So we've got our empty vector and our output. If we look at 1 to length X, we have the vector 1 and then 0 is going to be iterated for each loop. So in the first iteration, X1 returns NA, X position 1 squared also returns NA. Our first element of the out list starts out as null. We assign x1 squared into that, and we get out as a list with the first element being NA. And then in the second iteration, x position 0 returns an empty numeric vector. That empty numeric vector squared stays an empty numeric vector. A list of subset 0 just returns an empty list. So we're assigning an empty numeric vector to an empty list, which sort of stays an empty list. And that's where we get the final result being just a single element in our list. Yeah, so this one was really interesting.
Yeah, very.
When the following code is evaluated, what can you say about the vector being iterated? So we've got numeric vector 1, 2, 3, and for x in that vector, we're going to be taking x, the original vector, and appending x times 2, and then storing it back in that original vector. And the results that come out are 1, 2, 3, 2, 4, 6.
it's just added. It just append. It's an append,
Oh, and
weirdly.
it chooses what the values of X will be before it executes the for, it looks like.
Yeah.
because otherwise it would keep going.
Yeah, you're on the right track. In the loop, X takes the value of the
Yeah.
initial XS 1, 2, and 3, indicating that is evaluated
Yeah.
just once, right? So by changing the value of XS in the loop, we don't change the individual iterating values of X as we go through the loop. That makes sense.
But then it still happened the next, I mean, the
Yeah, so
updated result.
yes, I think the
It's
point
a combine.
yeah, it's a combine. So I think the point he's trying to make here is that this value of XS here that we run through for all these individual X's, when we change it down below in the loop, the actual value up here doesn't change. It doesn't affect that. It's set before we enter the loop. And so as
So
you
it's
overwrite the vector, we don't end up going X1, X2,
infinite.
X3, X2, X4, X6 and having an infinite loop.
So it's 1, 2, 3, 1, 2, 3, 2, 1, 2, 3, 2, 4, 1, 2, 3, 2, 1, 2, 3, 2, 4, 6.
Yeah.
Basically.
Yep.
I will be traced back that.
Oh no. How do I clear my annotations?
You're gonna
There we
keep
go.
it all day. Oh no, dang. You find the
Found it. Found it.
until Zoom update.
So what does the following code tell you about when the index is updated? So we have a simple for loop I in 1 to 3. We're taking I times 2 and storing that as the new value of I and then printing that out. And we get the result 2, 4, and 6.
Yeah, it's correctly updated. It's updated by each iteration. I mean, not the iteration. It's which was not the same at the previous one.
Yeah, so it updates the at the beginning of each iteration, it
Yeah.
updates it. Therefore, assigning the index during the iteration doesn't affect the following iterations. I think that was, yeah, that's our last quiz question.
Cool. Well, that's good.
Yeah, like I said, this was a short chapter, so kind of a short
I mean,
meeting this week, unless
who
there's
is
other.
dealing with function next week?
Yeah, so that one looks much longer.
Sorry, I was away from my desk for a second. Do you want to check? We have some new spots
That
open.
Sally, because like yeah, she said she got
Yeah.
some stuff.
So, apparently I didn't see your chapter 6. I want to make sure that she didn't put herself back on chapter 6, but I think I just missed that one. So, next week, she was going to present and she isn't able to participate anymore. And so, if someone else could take that, that would be great. I'll make sure that she's not saying that she can. But I don't think so.
Will be a positive.
Yeah. So that's the workshop day. I plan to
Yeah.
attend this meeting because I'm going to be in Atlanta, but I'm not participating in any workshops, so I'll just fall into this. Or I mean, we can skip. We don't have a lot of space in the schedule if we don't want to run into daylight savings in the spring. So I'm trying to avoid skips when we can. I guess, like, who can be here next week? Is there? mean, there'll be at least two of us. Okay, at least three of us. So yeah, we'll go ahead and meet.
I can review like you do it, John.
I'd rather not present it if
Yeah,
don't
I
have to.
can do it, but like I will
Okay.
probably have no time to review the exercise. I will just review the slide and the content.
No problem. With the tweak I
Okay.
made this last week, the old slides will work. You might have a lot of scrolling to do, but they'll work
Yeah,
at
it's a
least.
big chapters.
Yeah. And it is funny. Like, I think one of us early cohorts made the slides, and then people after us were like, well, these have been here for a while, so I won't edit them. And just looking back at them, they're a lot sloppier than a lot of the books are. Like you can tell
I was the
these haven't been edited
facilitators
that
of
much.
I was the facilitator of the preview, so you can blame me.
Yeah, it surprised me being on cohort 10. I thought sure they were going to be like all clean and good to go, and it does, like, looking back at the pull request, there hasn't been that many changes in this one, given
Okay.
that we've had 9 cohorts.
I
So
will look at it
like
then.
don't assume that the slides are going to be good as is.
I will not.
They're not,
I
it's
will
not like
review.
they're awful, but they were kind of before, well, they were before Quarto existed in a lot of cases, let alone that we had set it up to use Quarto. And there's there's a lot that could be better. They weren't designed really as a presentation. They're designed more like a book, a lot of them. So like
I
be
will
ready
look
for
at
that.
it.
Yeah.
Got it. Sure. I will try to update
Yeah.
that.
And if you apply the I don't remember what the name of it was, but the statement evidence or whatever that was called.
Should have it.
It makes for I really am a fan of that. It makes for good slides. So
I like it too. Thanks.
Okay,
Yeah.
how the slowing. Okay, I got you. I will see.
yeah. Anyway, so cool. Yeah, we're good to go otherwise though. And just let me know if like something comes up and you can't.
I will put my name.
Yeah. Because technically I can. Like I said, I don't really have any plans. I'm gonna be there Monday for the pharma thing. I'll be there Tuesday, just kind of hanging out, and then the actual conference starts on Wednesday. So
Perfect. Well,
all right.
everyone, I gotta go.
All right, I will see
See
you
you.
all next week.
Next week. See you next week.
Thank
All
you.
right.
Do you type end?
Oop.